Let's see how Geogebra can help us to solve the following problem. Two telephone poles are erected perpendicular to the ground and 40 meters apart. The poles are 30 meters and 20 meters tall. Two supporting wires are shown, each running from the top of one pole to the bottom of the other. How high is the crossing point of the two wires? In other words, if the wires were in the same plane, what would be the point of intersection for those two lines? And part B asks, the Public Service Commission has stipulated that the meeting point of the wires must be 15 meters off the ground. Show how this condition can be met by moving the poles either further apart or closer together, or show that this condition cannot be met. So let's start by clicking on this and deleting the text. And I'm now going to change my axes so that I can actually graph what I want to graph on here. The one pole was 30 meters tall, so my y-axis here is 30, and they were 40 meters apart, so it looks like I can get this on here graph the way I want to. I'm going to start by creating some circles. I'll go to here and choose circle with center and radius. So I'm going to have my center be the origin, and notice it gave me the point 0, 0 up there in the upper left corner. My radius is going to be 30, and so I'm going to construct a point here. Let me get the point. I'm going to get the point 0, 30, and I'm going to construct the segment from 0, 30 to 0, 0. That'll be the one pole. Line through 2 points. Actually, that should be a segment through 2 points. Let me undo that. Control Z to undo that. I want a segment through those 2 points. So there's my one pole. And my other pole is going to be over here 40 meters away, so I need to create a new circle. So we'll do circle by center and radius. My center is going to be at the point 40, 0. And my radius is going to be 20 since the other pole was 20 meters tall. And I'm going to put a point on this circle directly above 40. So I'm going to construct the point 40, 20 since the radius of the circle is 20. Notice the equations of the circles are being given over here as well as the points A, B, and C, their coordinates. But let me get a point here. And here's the point 40, 20. And I'm going to construct a segment between the points C and D to represent my other telephone pole. And now I'm going to construct the two wires from B to C and from A to D. And notice that GeoGebra gives us the equations of the circles. It also gives us the lengths of the segments, which we could find by using the Pythagorean theorem if we wished. Let's actually get the point of intersection. So to do that, we're going to come over here, point on object, no, intersect two objects. I need to find the intersection of this segment, BC, and this segment, AD. And the point of intersection is point E, and it has a coordinate of 24, 12. So it appears that the intersection of the two wires is 12 meters above the ground. Part B asks, well, what if we had the two points or the two poles either further apart or closer together? Could we have this point be 15 meters above the ground? Well, let's take a look here. Let's actually graph the line y equals 15, and I just typed that down here, y equals 15. There's a box down there at the bottom of the screen. You can't see it, but it allowed me to type that in. So this is the horizontal line, y equals 15. Let's move point C and see if we can get point E to be on that horizontal line. Doesn't look like it. Looks like it's actually continuing to have a y coordinate of 12. So it looks like that the Public Service Commission's requirement of 15 meters cannot be met no matter how we move these poles. Of course, then the interesting question becomes, why?